Alright guys, hi, so today we're going to be talking about what 2 bits are, what base 2 is, and we're going to be building a circuit to represent 2 bits, and then I'm going to show you how to write the code, and yeah, let's go ahead and get started with what base 2 is. So base 2 is nothing but representing numbers using 0 and 1. So each place value shows a power of 2. So the rightmost is 0 and then the leftmost, so it goes 0, 1, 2, 3. So let's use this as an example, 1, 0, 1, 1. So the first number is 0, the place value is 0. So that means it's 2 to the power of 0. And we have to multiply that by 1, which you don't really need to do. But yeah, so that's 2 to the power of 0, which is nothing but 1. And now let's move on to 1, 1. So that's 1 times 2 to the power of 1, so that would be 2. So that equals to 2. And now let's go to 0. 0 is in the second place value, so that's 0 times 2 to the power of 2, which is nothing but 0. And then 1 in the third place, so that's 1 times 2 to the power of 3. So you see how we're adding so 2 cubed whenever it is the third place value, and if it's 0, we multiply that by 0, and if it's 1, we multiply that by 1. And then in the end, we add all the numbers to see what number they're representing. So 1011 is nothing but 11. Why? Because the first one, 0. 1 times 2 to the power of 0 is 1. And the first number, 1 times 2 to the power of 1, since it's in the first place, which is nothing but 2. And then if you add 2 and 1, that's 3. So let's keep that aside, 3. And then 0, that's in the second place. So 0 times 2 to the power of 2, which is nothing but 0. 0 plus 3 is 3. And then 1 in the third place value. So 1 times 2 to the power of 3. 2 cubed is equal to 8 times 1 is 8. So 8 plus 3 equals 11. So now let's go on to 2 bits. So 2 bits is basically all the possible combinations that we can do with 0, 1, just 2 bits of 0 and 1. So 0, 1, 1, 0, 1, 1, and 0, 0 are all the possible combinations of base 2 using 2 bits. So what we need for a circuit itself is 5 wires, breadboard, 2 LEDs, Arduino, and 2 20R resistors. Real quickly, this is our diagram. So I'm connecting the first LED to digital pin number 8. I just put 1 there to make it more simple. And I'm connecting it through a 220R resistor, right? And same here, except it's connected to pin number 9. And then both of the cathode parts are connected to the ground. So now let's move on to our circuit itself. So first what I did was I took the longer part, which is the anode. I have to connect that part to the digital pin. So I connected it to a resistor, and then I connected the resistor to a wire, and then connected it to its digital pin, which for red, it would be pin number 9. And then I did the same for this part. I connected the anode to a resistor, which then got connected to a digital pin. And then for the cathode, aka the negative part, I used these 2 yellow and green wires and connected them to the cathode. And I connected both of them in a different row. And then I took a bigger wire, I connected it to the other 2 wires and connected it to ground, since both of the cathodes need to be connected to ground. So this is basically just a simpler way of doing it. So now let's move on to the code itself. So I used the Arduino board for this. So basically this is just our code right here. This is just naming our thing. So MSB, most significant bit, is equal to digital pin number 8, and same here, LSB is equal to digital pin number 9. And we're just naming it so MSB is equal to 8. So whenever I say MSB, I'm referring to pin number 8. And same here, whenever I'm saying LSB, I'm referring to pin number 9. So if you look here, pin mode. So in pin mode, basically what I'm doing is I'm naming whether the digital pin or is an input or output, which in this case our LEDs are an output. So I'm naming both of them as an output. And now we're going on to our wide loop, which is what makes the 2-bit counter. So the order we're going in is 00011011, which is the binary sequence. So you have to go in this order. Over here, I didn't put it in the order, but I made a mistake in that. But you always have to go in this order. Remember that. So now let's move on to here. Digital right, that's just saying whether our LED will be low or high. Low meaning that it's off, and high meaning that it's on. And then delay, 1000, it counts in milliseconds, so 1000 milliseconds is 1 second. So low, 0, and then after that, for 1 second, it waits. And then over here are binary 0, 1. So here we're doing the binary 0, 0. And then for here, we're doing binary 0, 1. So our least significant bit, which is pin number 9, turns on this time. So low, high, and then delay it for 1 second. Same over here. This time we're doing binary 1, 0. So MSB would be high, LSB is low, delay it for 1 second, and then we just do it for 1, 1. So now let's see if our LED works. So first let's go ahead and plug it in. Yep. Okay. So let's click upload. Yep. It's compiling the sketch. As you can see, it's turning on slowly over here, taking some time, and it's done in 3 point something seconds. All right, now let's check it out. Okay, that's 0, 1. That's 1, 0. That's 1, 1. 0, 0, 0, 1, 1, 0, 1, 1. 0, 0, 0, 1, 1, 0, and 1, 1. And I think we're done just like that. If you want just to see a better view of the circuit itself, here you go. And make sure that you're using 220R resistors. If you want, you can use a 330 ohm resistor. But if you go below that, then it's just gonna let through too much current and your LED is gonna burn out. If it's bigger than that, then you're just gonna let through too less, so your LED won't light up at all. And then here's just some wiring, the big one to the middle, just like that. And then some notes that you can take for the future. And then take a real quick peek at the code itself. Yep. And just like that, we're done. Hopefully you enjoyed the video, and thank you for listening, and hopefully you learned something new.